Welcome to the highlights of the Circular Republic Festival, Europe's leading event for advancing the circular economy, uniting corporates, startups and innovators driving this transformation. We continue this series with a panel about the role of robots. The panelists are Fridolin Franke, co-founder of Solar Materials, Rebecca Zhu, head of growth at Circu Li-ion, Tobias Ortmaier, co-founder of Voraus Robotic, and José Saenz, group manager assistance, service and industrial robots at Fraunhofer IFF. But before we start, I have an offer for you. If you want to get the actionable one-pager of this conversation, please sign up to the Circularity FM newsletter. You can find it at www.circularity.fm.
Hi, good morning, everybody. This is quite a party. I mean, the jingle was really nice. I feel like I'm on some type of game show. But we're not on a game show, but we're talking about very serious things. And so to kick us off, I mean, I think you guys probably looked at the title of the session. It's called Drill, Baby, Drill. And to kind of, not to scare you off, but I want to make this an interactive session. So please participate, ask your questions. We're not going to do a 45-minute session up front. We want to make it interactive and actually get questions from the audience. So feel free to chime in. And the first question I'm going to ask straight off the bat to the audience is, what was the association that you had with Drill, Baby, Drill? I see a couple of people smiling in the audience. Yeah, feel free. We have a mic going around. Please share what your association was with Drill, Baby, Drill. And maybe you're kind of questioning as to what do we mean by this?
Drilling for oil industry.
Nice. And then does anybody know where that exactly comes from? Yeah, so it was actually first started or first used in 2008 by a Republican as well, and then was kind of used again in the whole Trump going up to the presidential election by the Trump team as a Republican battle cry. But of course, seeing as we're here with Circular Republic, that's not what we're going to talk about, right? That would be kind of weird. We are here today to talk about automated disassembly. So different type of drill, baby drill, the better type. And with me, I have three esteemed gentlemen who I'm going to introduce in a second. And we're really here to talk about automated disassembly in the sense that being kind of the most pivotal kind of step in allowing for product extension, for reuse, for remanufacturing, but then also for clean recycling. So these gentlemen have very illustrious careers, so I need to take out my notes. But starting with José, we have Dr. José Saenz, who leads the Systems, Service, and Industrial Robotics Group at the Fraunhofer Institute of Factory Operation and Automation in Magdeburg, focusing on the safe human-robot collaboration, mobile manipulation, and automated disassembly to contribute to the circular economy. As a board member of EU Robotics AISBL, he also plays a key role in shaping the future of industrial robotics in Europe. So welcome, José. Next up, we have Tobias, who leads the Institute of, previously led the Institute of Mechatronic Systems at the Leibniz University of Hannover for 12 years. Always had a passion for technology and kind of spin-offs and taking the transfer of technology into the industry. He is now the co-founder of Voraus Robotic GmbH, which has set out to become the Android of automation technology. Welcome, Tobias.
Thank you.
And last but not least, sitting to my left, we have Fridolin, who is the co-founder and managing director of Solar Materials, a deep tech startup pioneering the recycling of solar panels. They also have a booth upstairs if you don't want to check it out later. The company recently launched its first industrial scale plant in Magdeburg, Germany. Unlike conventional shredding-based processes, Solar Materials has developed a fully automated disassembly reverse production system that enables the recovery of all materials, including silicon and silver. To enable cost-effective and scalable operations, their approach is driven by automation, data, and process intelligence. Welcome, Fridolin. Great. So to kick us off, maybe from your guys' words, right? Why is automated disassembly such an important building block to a functional circular economy? Maybe let's kick it off with José.
Yeah, Because there are so many reasons. When I start talking about the reasons for automated disassembly, it's because we don't have enough people. It's because it's work that people don't want to do, that it's not well paid. But we still need to get at these materials. Dumping them in the ground or sending them to Asia or to Africa, that's not the solution. And what we're seeing is then from the other side, we want to be able to access these raw materials and, sort of being held at the end of a long gun by Russia. China is also maybe not the friendliest partner, and they're supplying us with all of these raw materials. And the question is, can we supply them somewhere else? Yeah, and we have so many things here, and can we use that? And it makes sense. And if you talk to kids about this, or people who are not so deeply in how things have to be, but how things could be. For them, it's obvious. Yeah, sure, we should take things apart and reuse it. Why not? I do that with all my toys, right? Why can't we do that? And I think automated disassembly is one tool that, if done correctly, could be useful and could be really helpful. But there are lots of pitfalls. I'll let somebody else talk about that then.
Yeah, I totally agree on that. So when we started our company, like in 2020, we came across the idea of solar panel recycling, we realized that with the standard recycling approach of shredding and sorting, it's just not possible to extract all materials out of these solar panels. So we thought about, okay, how can we think recycling in a different way? And we came up with the idea of building this kind of reverse production. And as one part of that, as you mentioned, so it's just like one building block. We are also focusing on automated disassembly, so exactly to reduce the manual labor. That's a huge issue already in Germany, but all over Europe. So when we look at how our society will develop over the next years, this will be more and more important to minimize these easy manual labor steps and automate that.
You guys kind of alluded to it just now, and this is maybe a small side question, but I don't know how familiar the audience is with the current status of the industry, but can you maybe share a little bit as to what it currently looks like and what is happening in the world right now? And are we recovering resources at all, or are we not? What does the recycling industry look like today?
So when we started with what we're doing, we talked to many recycling companies, and everyone was kind of blocking the idea of using robots, for example. So everyone was like, no, you have to shred things. But if you look at what kind of materials we use in our modern society, so all of these critical raw materials, they are often inside the products in relatively low amounts. So it's really hard to extract these rare earths or silicon from chips inside mobile phones and so on. So with the shredding and sorting, you won't be able anytime in the future, from our standpoint, to extract these materials again. So you have to think different to recover these materials, and then also reduce our dependency on countries like China or Russia, if we really think about the geopolitical situation.
Yeah, maybe just to pick up on that, on this idea of shredding, maybe if you're not familiar with it. So let's talk about a car. A car gets stripped down, the motor, the gearbox gets taken out. Maybe that can also be reused or remanufactured, and the rest of it just gets crushed. And then that goes between these big teeth, and that gets shredded. And then there's this just big mess of everything. And then with the magnet, I can get all the metals out that are magnetic. And then I can maybe put it in some kind of a fluid and get the plastics out because they'll float to the top. They're a little bit lighter. And I have these weird processes where I can start getting at certain things. But as you can imagine, if I just shred all the plastics together or all these other things, the little pieces, they're not coming out. We had a project with mobile phones and with PCBs. And in that project, we actually had partners who were on the PCBs. They looked at it, engineered, and said, okay, there are very valuable materials within the components on the PCB. Let's take those off. And then they realized if I take those off and just, for example, the tantalum capacitors, and if I just recycle those, all of a sudden I'm able to get that out and reuse that, but I couldn't have out of this big process of just shredding, right? So if I take things apart into very fine sort of fractions, I have a chance. But it's still, so it's possible, but it's not sure where the economics are yet.
Absolutely. And maybe I wear two hats there, but maybe just to add a little bit from the battery industry as well. So, we at Circu Li-ion are dismantling or automated in an automated fashion dismantling battery systems. So ranging from electric vehicles to energy storage systems to also smaller systems like power tool, micromobility, etc. And with, for example, EV batteries, the current status of the industry is that they're manually disassembled, right? So there's actually two operators disassembling systems for 2+ hours, depending on kind of the product design. So it's a very, very manual process that also is very dangerous, poses significant risk to health and safety, and are also complex. So there's very little process consistency. So also another challenge kind of the industry, and kind of an insight into the status quo of what it actually looks like to then be able to either reuse it or to bring it into clean recycling. Okay, to move it forward and moving a little bit more to the technology, which I think is also up to Tobias's alley. So how can we increase the flexibility of disassembly systems to keep pace with the growing product diversity and shorter product life cycles?
Okay, that's a good question. So maybe if we look back in history, so where basically come robots from? So robots were invented last century, and their main duty was to do repetitive tasks for a very long time, always the same thing. So spot welding, for example, producing cars over a period of 5, 6, 7 years, and the robot basically was programmed once and did this 24/7 for several years, basically. So there was never the need to make things flexible. The main focus was to make things robust. So this was the core topic or the core KPI of robotics industry. So availability of the system. So and that's why all the components, robots, and especially software were designed not to make updates very frequently or to modify things, but to make things robust. So that's basically the thing or the starting point of robotics. And now what we need to do if we look at all these different things which need to be recycled, dismantled, whatsoever, so we need to focus basically not on the mechanics, not on the hardware, but I'm very sure we need to focus on sensor technology, intelligent sensor, we need to focus on artificial intelligence and on software. And I think for all these challenges you guys were talking beforehand, basically it's software which enables or which increases the flexibility in recycling or dismantling.
Great.
So it's software.
Yeah, I can totally underline that. So this is exactly the challenge that we're facing in our day-to-day business right now. So like the standard industrial robots, they are produced to do more on the production side and aren't so flexible. And for us, the challenge is from a recycling point of view that we don't know what we get before we have it in front of us. So then we have to adapt our recycling processes or disassembly process exactly to what we find there. So one example is for the solar panels, there's a junction box on the backside. And sometimes, or most often, it's in the middle and in the top third of the solar panel, but sometimes our newer modules have, for example, 3 different junction boxes, and we always have to identify where these are. And then there are cables, these are flexible, so you cannot just say, okay, it's every time you have to check it there or there, but you need some kind of visual analytics to identify where it is, and then also combine that with the robots so that you find where these parts are. And this is, I think, similar to what you're facing with all of the screws and so on that you have to remove.
Yep.
Maybe,
Yep.
if I can add a little bit. So basically, if we look at the software, so we have the so-called OT technology, which means operational technology. So the software that runs the robot is part of OT. And then we have the IT software. So, I mean, we all have a smartphone, and if there is a software update, I just click on maybe 2 buttons and that's it. But that doesn't work in industry because these worlds are somehow separated. So even if you have the information of a solar panel, how to dismantle it, this information somehow needs to be transferred to the plant and needs to be interpreted as, let's say, new robot programs, so new movements, new motions, and there is a huge gap. And if in industry, if there is a software update in OT, So I'm not kidding, but people have a USB stick and they run to each production plant, put the USB stick in and do the software update. And it takes basically hours. And that's one of the reasons why flexibility is very cost intensive and of course risky. Because if you change something and you have no chance to do a simulation in advance, for example, to check if the robot may crash, if the solar panel, for example, is all within the workspace of the robot and so on, you are not sure if your system will be running and will be stable after the software update. Well, that's a big issue at the moment.
Yeah, so I can just pick up on that and try to paint a picture for you. Production with robotics is hard, and these robots are blind and they're doing the same thing over and over again. And what we have now in the disassembly process is we have not one product that we're focusing on, but a whole range of products. We have no idea what's coming. That means we need sensors, we need to be flexible, we need more understanding. And of course, if I think about this kind of a robot application in the normal production, it's going to be more expensive than the cheap blind robot that's doing the same thing over and over again, right? So I need a more expensive robot that can be more flexible, that can do more things. And right now in Germany, we had, I want to say in 2023, around 26,000 new robot applications. That's how many we have a year, and those are the cheap ones. And now we're saying we need more applications, but they got to be way more high level. And there's no way that we can do this, that we can have these high-end, super expensive, flexible, shiny robots with AI. But they also, how can we do that, right? So, and that's where you're coming into play, that's where we're coming into play, and we think that this, the ability to have quicker and simpler programming techniques will save on it, so that even though it's more complex, it's actually reducing my engineering costs in the long run. So there's a big opportunity there.
And maybe we are always talking about robot, but robot is one part of a production plant, one part of an automation cell. So we have actuators, we have sensors, we have I/O signals. And the next big thing is a robot usually is programmed in a vendor-specific language. So KUKA, for example, is KRL. The other components are programmed in another specific language, so it's structured text. So both date back to the 70s, last century. So basically Pascal, so if you're probably my age, you know Pascal, a little bit outdated, but basically that's the core. So structured text, KRL, and then you have all these new fancy sensors, smart cams, programmed in a different language. And putting these things together and enable updates for an entire automation plant, that's really difficult because you have so many different components, so many different languages involved, and they need to work seamlessly.
Yeah, I mean, the technical experts here on my left, but maybe also adding one more facet of kind of I think we spoke a bit about now, the challenges of automated disassembly, right? And what it takes to make it work. It's not as trivial as, okay, we put a robot there and then it, repeats the same thing. But instead we have, very much varying input, right? That needs to be processed. So no end-of-life product will look the same, which is key, and very different to assembly, right? Where you have, different steps and they all look the same because, it's all perfectly defined before. So that's very much a challenge that we see in the industry and kind of, I think, needs to be given the sensitivity of the topic of automation, right? What does it take to really bring automation into an end-of-life scenario? But now we spoke a lot about the challenges. What are the opportunities that you see kind of with bringing automation technology into disassembling products such as solar panels, and what benefits does that really bring us?
So when you're able to bring it up and running, so what we did, luckily. Thanks.
And also, guys, feel free to ask questions, right? Like, if there's any questions from the audience, feel free to kind of chime in and raise your hand. We're happy to take questions.
So just in the beginning of our recycling line or reverse production line, we do these disassembly steps of cables and junction box and also pick it up from the pallets. And this is all done with robots. And normally, if you wouldn't do this in an automated way, you would always need 2 to 3 people per shift. So when you're operating an industrial plant, like in a 4-shift system or 5-shift system, this means, you need like 15 workers, worst case, to do these steps. And now we have 3 robots, and the return on investment is really, really good. So I would say like after 1.5 years, it's already profitable to do it this way, how we do it. So there are definitely huge business opportunities to automate things and work with robots. But of course, you have to adapt it to the different products. So solar panels, so we also have like 50 or 60,000 different solar panels, but in general they are all like a rectangular structure, so that's a little bit easier than, for example, TV with different screwing and gluing techniques and so on. But so it is possible to do it, it is economical, so I can just encourage everyone to try it and develop it. But as you described before, it's really important to find easier ways to program these things.
Yeah. So what's changing, right? Why is it easier now? Why do we think that it's even possible? We had an EU project in 2019, and we were taking mobile phones apart. I mean, the old ones, the Nokias, with screws where you could change the battery yourself, right? The 6230i and that whole family. And we were taking them apart, and for every mobile phone, we had a special fixture, and we had a program, and it was only for this phone. And the recycler said, yeah, we have somebody beforehand who sorts them, and then we have 10,000 in a batch. And if there's 1 or 2 that are wrong, we'll just sort them out. But that's not how this works, right? I don't want to have somebody sorting them. I just want to have everything comes in, it's jumbled, and I want to take that apart. And that's where we said we need better ways to do this. So AI, everybody's talking about it. And we always like to say as much as only when necessary and only as much as we need. But we see with AI, there's this crazy opportunity, one, to identify what are these components that are coming in. We did a test with old PCs from our lab in the basement. They were 15 years old. The first thing that we did as humans was we looked and said, okay, what's the name, who's the manufacturer, and what type is this? Dell T3100. Then we looked online. Is there a manual for it? There was, even though it was that old. In the manual, it says how to open it, how to take things out and put things in. And then we said, okay, let's give this to ChatGPT. Here's a manual. How do I open the computer? What tools do I need to do this? This is all possible now. It's mind-blowing, right? So we talk about robotics, but it's also a big data problem. If we have data about the products, then we can start making disassembly sequences and use that to make automatic programs. So we're doing that right now, and it's working a lot better than we thought. So we can detect what these systems are. We can look for information online, and then we still have people in the loop. We'll always have people in the loop. You know, even if I have a perfect model of this PC, maybe somebody changed some things during its life cycle, and that's also the tricky part. Is that during the life cycle, these products get used, they get dusty, and they're not perfect, and we have to deal with that too. So there'll always be somebody there as like a helper, a teacher, and what we're also working on is how to make sure that the person who is in the loop is also in the digital loop, so that anything that they are changing, updating, fixing, helping, also gets updated into our digital twin model of the processes that we're using for disassembly. And then on top of that, we're using AI to generate robotic actions so that we're not having to program. And if you can imagine taking a main board out of a computer, if you've done that before, it's really tricky because it gets stuck everywhere. There's little metal parts and the connections that are outside, so I have to sort of move it around inside. And I'm only using my force in my fingers to take this out. And we have programmed robots that can do this with an AI agent, so it's not really programming, it's just trained an AI agent, and the robots can do this as fast as humans. We have a question.
Oh, awesome. Well done. Oh, there's another question. Okay, great. Let's get some engagement.
First of all, great to hear what's all possible. But I would be interested in how much design for disassembly or design for recycling would facilitate your job.
Great question. That was actually going to be one of our points later. Gentlemen?
Yes, please. Right? But nobody does it. It's not. I talk with manufacturers, white good manufacturers. They say microplastics, people washing their jackets, it's a big problem. They said it's no problem for us to put a microplastic filter on all our washing machines, but nobody wants to pay for it. Right? So design for remanufacturing, recycling, it's more a question of are we willing as consumers to pay for it, and is there a market behind it? So we're talking technology here, but it means nothing without the market, right? So we're trying to also stimulate that and put that together and get these. There is no market right now even there, so it's really trying to sort of start from scratch and building that up, and that's the tricky part.
Maybe I can add some words. So I think all information that is available and helps to disassemble things is very important, as you just said, in order to train an AI, for example, because what you don't want to do is you don't want to program your robot or your disassembly plant each time manually. That's far too cost expensive. But if you have an AI and you can train it, of course, new data always helps, but still what you need is a digital twin, because before you deploy a robot program or program to the production plant, you want to make sure that it's working. Yeah. Because if you have a crash, then everything stands still and some guys have to come, fix it, repair it, you have to wait for spare parts, and that's super expensive. So besides the information you can provide, I think it's also very important to have some simulation beforehand to make sure that everything works well, and that's also information that could be provided by the manufacturer of the good. If they do it, I doubt.
Now you're inciting conversation. Yep, go on.
I have a question for you, Fridolin. So we're talking about data, and we have this idea that when we take things apart, if we also collect data on the processes, how good did it work, how fast, what were problems within the specific product, that we can actually monetize that and send it back to manufacturers in the idea of design for reuse, recycling, disassembly. Are you collecting data, and are you figuring out, looking in that direction to feed that back to manufacturers?
Yes, we collect data. So we have this huge database where we have like in total 130,000 solar panels inside. So it starts with the different sizes of a solar panel, so that our machines can adapt themselves to the different sizes. So we can handle from 1.20 meter to 2.40 meter in length, for example. But then it gets more into detail, so like the glass thickness or what kind of plastic foils are inside, because based on that we have to adapt our processes. And we've been in touch with several solar panel manufacturers. Most of them are located in China, and they are a little bit interested in how good some things are to recycle. But in the end, it's often decision to still go with a junction box with 3 different thermoplastics, because the people in charge right now don't care about what's happening in 20 years from now. So the solar panels have a really long lifetime of 20 years plus. So this makes it hard to convince these people outside of their own will to change things. And I think there's more like a political direction needed, so that this will be really changed.
Any politicians in the room here? Yeah.
I guess it's super cost-driven, right? So if a change increases the cost of the solar panel, I guess it will not be implemented.
Yes.
At least that's my gut feeling.
Yeah, so I can also add to this from kind of an automotive perspective, which is, obviously kind of with batteries, that's one of our main customer constituents. And so what's really interesting there is that there's kind of a shift in discussion, right? So I think a couple of years ago, designing for circularity, designing for recycling, not really a thing, not really anything anybody spoke about. And I mean, in automotive, you also have very long development cycles, right? So now they're developing in 10 years or so. But what's happening now is that, especially with the regulation that you have in Europe and with the increasing recycling costs, et cetera, there is more discussion about it, because what OEMs have come to find out is that a lot of and I don't mean to step on anybody's toes here, but I think this is truthful conversation, but they found out is that a lot of the batteries that they're producing are impossible to disassemble. And the trend is actually becoming more and more so, because there's very strong adhesives used that are not debondable. There is really no thought at the design stage of how can you disassemble the pack. And that's becoming more and more of an issue now, because, with increasing production as well, with battery design moving from cell to module, which is still kind of a disassemblable structure, to cell to pack designs, which are pretty much cells just immersed in a pack, but filled with glue, and so to drive kind of performance and energy density. But now they've come to find is that in terms of, for example, end of line for production scrap and so, the packs are not they're not able to disassemble those. And so that incurs kind of a cost on the OEM again, as well as for recycling at the end of line or at the end of life, which they now are starting to factor into their own equation. So, the conversation is starting to change a little bit in terms of actually costs that are coming to the OEM as well, which is now kind of changing, I think, also the mindset around it. So it's not so much just we're doing it for sustainability, but it's actually now becoming a cost point as well for the OEMs.
Yeah. As an engineer, I like to say what we need to do is we need to widen our list of specifications, the requirements on our systems. And nobody's putting that at the beginning, and they're saying we could do it, but it costs too much. But it's going to need to come from somebody, and probably from the regulatory side, because everybody wants to be greener, but it's really hard unless it also makes economic sense. Yeah.
Mm. Good. So we touched upon a lot of different questions and topics. So we talked about challenges. We talked about a little bit of the technology. We talked about a little bit about the economics. Is there anything specific that you kind of want to share with the audience that you want to dive a little bit deeper into? How do we bring automated disassembly to life, and how do we really bring it into practice without just being kind of a, hey, this is what we should do and this makes sense, but how do we make it work in reality?
Yeah, so I have a take-home message. I worked on it all night. No, I'm kidding. And the take-home message is right now, there's these huge opportunities using AI and using robotics to make this flexible type of disassembly situations. Now, what you have to realize, though, is that the robotics are not disassociated from the hardware. That means that if I have a certain disassembly process, if I have wires, I'm going to need wire cutters. If I have screws, I'm going to need a screwdriver, or I'm going to need some kind of a drill. So my hardware is really closely tied with the types of products that I'm taking apart. And I think what's really an opportunity right now for different industries is to start piloting and testing what kinds of tools and combinations and setups are needed and are potentially useful for individual product types and classes. And I mean, we've talked about computers, we've talked about batteries, we've looked at solar panels, we have discussions with white good manufacturers, we've had discussions with people who were doing giant valves in the process industry. And once you start getting into it, you realize that there are lots of different industries where there's lots of material that gets changed out yearly in the process industry, or old PCB boards from telecom that are going from 5G to 6G and those kinds of things. And exactly for these kinds of processes, it makes sense. And I would just really ask you and suggest that you start experimenting now, because the advantage that you'll have when you know about the possibilities, it'll be available in the next 3 to 5 years. Yeah. Mm-hmm.
Maybe also with that note, or on that note, a question to the audience. Do we have anybody in the audience that is from an OEM side who has looked into disassembly of their products to salvage resources and maybe even looked at automation? Oh, yes. Can we hear what kind of your experience has been, what the product is?
I am Dragan from Apple. We have done a lot of in-automatic dismantling. Had several robots right over 7 years now, like the newest one, Daisy. Yes, we worked a lot on it. We worked also a lot on repair, reuse, refurbishment. So you need the entire system to work, and dismantling is only the last piece when nothing else helps. And even then, it's a lot of work. I agree. It's to make it really usable, and even with dismantling, like the process does not stop there. You need to recover the materials out of it. So even if you have components, you still need further work to take out the materials and bring them in the loop. So it's a big, long, lengthy process that starts with design and ends up with chemistry.
Absolutely. Great. Yeah.
Quick question in that. Yeah. Actually, probably without, right?
Yeah.
In that context, is it intellectual property a risk for you to share information of assembly so that you could theoretically pass it on to a disassembler? If they had your plans, right, disassembly probably could be easy, right? Or the IA tool could learn it, right? So could it be part of the electronic product pass to hand over the design?
So we have already published recycled guidelines for all our products. You can find them on the internet site underneath every product. You have the recycled guideline. There you can see where the specific materials are located and what it needs to be taken out on the recycling, not by using normal tools, like what a recycler will do. So these guidelines are available already for several years, so you can have a look. They are there already.
So no IP.
No, we publish them, and also for our developments like Daisy robots, we also give the free license. So if anyone wants to experiment with it and use it or further develop it, they can come and contact us, and we like to bring forward that for everyone.
I think the big advantage of what you're doing is that you have a limited number of products. So at Apple, because it's not because you're one producer and you have many iPhones or MacBooks and so on. But when we look at the overall communication industry, then we have, I don't know how many thousand different phones. And if you're not like a producer doing the recycling, then you have to get the data for all of these phones to be able to disassemble that. So the question is really, how can the recycling companies get the data of the structure of the products, and then this would enable also the robotic disassembly.
Yeah, so digital product pass is a huge topic. We were involved in a Senelec standard where we were looking at guidelines for people who want to create their own digital product pass. And the question was, what needs to be inside? And our contribution was pretty simple. We said it should contain information about disassembly processes. And what we didn't want to do was define that too heavily because it's still sort of growing. I mean, even for us, our disassembly sequences, we've defined them, but they could be different in terms of how they're worded, how they're done. So we didn't want to get too much, just an overall guideline, thou shalt provide some information on this. It's nice. How standards should be done. I don't know if that wording came into the standard, but yeah.
I encourage you to look at the recycling guidelines and give us feedback. So if you like them or not.
I didn't know they existed. We'll exchange, and you'll get back. I'll get back to you within a couple of weeks. Yeah.
Not a lot of people know that they're existing, even though they can be found underneath every product, basically on the internet side.
Okay, we have a question here.
Last one, I missed my moment before, but what was curious to ask Fridolin, how did you achieve it? Can I go out to the market and order a standard reverse plant line, or how does this work?
No, so we started developing, or we didn't start with the disassembly in the beginning because in our mind this was the easy part of what we're doing, because we started with the delamination technology. So the solar panels are a bit like a sandwich structure, and we focused first on removal of the glass, removal of the EVA foil, then recovery of silicon and silver. And then at some point we realized, okay, there are also junction boxes and cables, and they need to be removed. And in our mind it was easy to automate that. But then we realized, okay, it's not. This is also, I think, how we got into contact. And then we worked together with special equipment manufacturers, and they built production lines for the automotive industry, for example. And they thought in the beginning, okay, it will be easy, but it took us many, many hours to really get to the status quo. And one big challenge here, what I would also like to underline, is that there aren't so many automation technicians who are able to really do that with the standard robots. So there are way more people being able to use Python, or I don't know, I'm not the digital guy in our team. And they can do the AI analysis of pictures and so on. But then the transfer into the PLC system is like really, really tricky. And this is why this is a huge enabler, so that you have more workforce being able to program these disassembly lines.
So it could be a good business as well.
Yes, definitely.
Great. Any last questions from the audience? Oh, yeah?
The examples you've given so far have been hard products. Do you think automated disassembly would play a role in soft products such as clothing and other textile products?
Really good question. And I've been talking with lots of people here about textiles. I know in the EU robotics, that's also been in the robotics community there. People that are working on sustainable robotics, they're looking at textiles as well. There I've heard them talking about, how can we automatically remove zippers and things like that. Super crazy challenge, but I think those are exactly the kinds of things where these flexible products with AI for detection and also for my handling strategies, that it's going to be possible, where 5 years ago I would have said, I'd really love to help, but I'm sorry, I have no options, and it's coming. So that could be that's something where you should really be in touch with your local robotics expert, and
if you have one at hand.
Yeah. So yeah, that's definitely a possibility. Yeah.
Yep. I think there is one, just to add to your comment, there is one important topic, as I mentioned before, that the IT world is somehow separated from the OT world. And what we need to do is that we somehow link all these new enablers we have, so high-level programming languages, AI, computer vision, we need to link it closely to the operation technology. And that's, I think, one of the biggest challenges we are facing at the moment in order to increase flexibility and, of course, to solve this labor shortage problem. I mean, it's not only manual work, but it's also robot programming. So I think we have 10 million Python programmers worldwide, but we have only 20,000 robot programmers worldwide. That causes really pain.
Yep.
Yeah. And PLC programmers, I hear they get paid even better because there's even fewer.
So they all drive these fancy Porsches, I guess, yeah.
Great. So we're coming to our end. So to wrap it up, so we heard lots of different topics being discussed today. And this is really what we wanted to do, is shed some insight into what it means to really disassemble, but do that in an automated fashion, and kind of the challenges, but also the great opportunities that we have behind it, touching upon the ROI. So we've heard it works. We had a lucky member in the audience where it also works. We touched upon kind of a digital passport that's instrumental also in creating kind of a shared data platform, right? Or giving people that are actually at the end of line or end of life to really access the data to be able to disassemble the products. We touched upon the technology aspects of it. So maybe looking at my fellow panelists now, what are the kind of last takeaways that you want to leave with the audience today? And maybe also kind of a teaser question as to where do you see automated disassembly in 3 to 5 years?
Yeah, maybe I'll just leave you with the idea, drill, baby, drill. It can be a good thing. Yeah, we're taking it back. Yeah. So that's my statement.
Good statement.
So my statement is increase flexibility by linking IT and OT technology, because this is the key. If we don't solve this problem, we will not be able to deal with the variety of different goods and products in recycling.
Yeah, and from our point of view, it's a huge business opportunity. So it's not just about reducing personnel costs, but it's also increasing our raw material revenues. So, of course, it's not just the robots, it's the whole automated system that we developed, but we double the recycling earnings per ton due to what we do compared to classical recycling approaches. So, yeah, I can just encourage everyone to try it for that product.
Great. Thank you so much for your attention. It was great having you. Thank you for the thoughtful questions. Thank you to my panelists.
This was another episode in our series about the Circular Republic Festival 2025. If you want to get the actionable one-pager about this conversation, please sign up to the Circularity FM newsletter. You can find it at www.circularity.fm. Let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination. My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.